So this video is going to introduce the concept of OR probability. What that means is basically, like if you look down here, the probability if I pick one of these shapes, it would be red or blue. So it's dealing with just the word OR and a probability. Before we get to that though, I want you guys to try to answer these top 3 probabilities just as a good quick review of how you find a basic probability. So pause the video and find these, and I'm going to go ahead and talk about them now. So the first 3 are not too bad. The probability that your shape is going to be red is going to be 5 out of 10, which is either 1/2 or 0.5. The probability that it's blue is going to be 3 out of 10. And the probability we get a triangle, there are 5 triangles out of 10, which is again 1/2. Now, if you look at the bottom 2 here, this is an example of, like I said, OR probability. We want to know the probability if we pick one of them, it's going to be red or it's going to be blue. So in this scenario, we would win if we pick a shape and it's red or it's blue. So as long as it's not black, we're okay. Now, if you look at this, a good strategy for this one might be, well, the probability, you could just kind of add them all together, or you can think about it. There are 5 reds out of 10, plus there are 3 blues out of 10, which gives you 8 out of 10, or if you reduce 4/5. And that actually is correct. Out of the 10 shapes right here, the only ways you would lose is if you got this one or this one over here. So those 2 are outs. That is 8 out of 10. So that makes sense, and it seems like when you see an OR probability, you can pretty much just get by with adding the 2 probabilities together, like we did right there. We added those up, we got 8/10, worked out. If you look at this next one though, the probability of red or triangle, we already saw if you do red, that's 5 out of 10. Triangle is going to be 5 out of 10. So in theory, this should give us a probability of 10 out of 10 or 1. So what that means is no matter what, we will win. If you're trying to get a red or triangle, there's no way you can lose because the probability is 1. But if you look at this, we would lose if either of these shapes came up again because they're not red and they're not a triangle. So the question becomes, well, here on this number 4 here, we added them together, we were great, we got the right answer. On this one, it did not end up working out. In fact, the probability here, if you're red or triangle, basically everything over here is going to win. These would still lose. It's still supposed to be 8/10. The difference in these 2, red or blue, is totally separate. You're red or you're blue and you're good. Or you're black or something. You can't be red and blue. There were a couple shapes here, though, that are red and triangles. So what happened was you counted them when you said red, and then you counted them again when you said triangle, and that threw off our answer. There's actually a vocab word for what's going on right there with that. I guess I'll write on here first. The probability is actually 8 out of 10. We'll get to why as we go along. So the difference in those 2 probabilities is something called, involves a vocab word called mutually exclusive events. Events are mutually exclusive if there's no overlap between them. So they are totally separate from one another. If they're not mutually exclusive, you could have some overlap, some stuff in both. So going back to our first slide here, the red and the blue are mutually exclusive. There's nothing that's red and blue. But triangles and red, for example, is not mutually exclusive because these right here are in both. So in this video, I just want to identify whether or not 2 events are mutually exclusive. So if we're looking at this bottom part here, we're going to roll 2 dice, and we're going to add the results together. We want to know if the events here and here and here and here are mutually exclusive or not. So the first one says rolling a 6. The second one says rolling an 8. We have all the 6s over here. We have all the 8s over here. There's no overlap between the 2 of them. You can't get a 6 and an 8 for your total roll. So this one, yes, they are mutually exclusive. So yes, they are. The second one says, okay, we have sum of 10 over here, and we have more than 5 over here. So is there anything that counts in both? And in fact, there is. If you roll a 10, exactly a 10, fits over here. It also fits over here. So 10 is in the it's like there's overlap between the 2 things. That's not mutually exclusive. So this one is no, because 10 is overlapping. 10 is in both. That's basically what's going on when you're talking about mutually exclusive events. You got to be able to pick those out.